So, hey everyone, I'm Marcin Lasak and I'm front-end developer at Divante, and I want to share with you a few of my thoughts on performance being quite important, or even the most important feature. So, usually, when we talk about performance as a front-end developers, we often discuss topics like website load times, page weight, CPU memory usage, lighthouse score, response time, layout shift, and so on. However, that's not something I want to discuss today. Also, let's leave the memory usage part of performance to Łukasz and his talk. It's really not that hard to create performant page today with all the tooling that was created with just this purpose in mind. And as we get more and more tools to help us with our jobs, we lose simplicity of our setup. And that often results in degradation of our efficiency as developers. And the crucial mechanism for our performance are feedback loops. They are everywhere. If we look closely at our environment, we can identify quite few of those loops in our work, from very short loops spanning just a few seconds, like the one during development, when we change code, run the code, test, or run the tests. Then we validate our understanding, and then we repeat the process again and again. And also with a bit longer feedback loops where we, for example, implement a feature, deploy it, and get a feedback from the user when it's running in production. So usually when we think about automating our feedback loops and making it faster, we try to move from manual work into scripts. And that's the first step to do it. Later, we need to also look at the performance of the automation we did. I think some of you saw this image already, how much time we gain by automating short, long tasks, depending how frequently we do that. That's, however, only one metric this chart is showing, the time gain by doing so. And that's not the only change that will happen once we shorten our feedback loop. We also got safety. We will do everything in proper order. We won't miss anything. We also don't lose our focus and attention during some short tasks or context if we have longer feedback loop. And this chart shows effects over 5 years for a single person. So the benefits can really be seen when we apply it to a huge team, for example, of 20 developers, where we shorten our build of application from 10 minutes to 1 minute. And that's the savings that are really mind-blowing. And it's good to start with changing our thinking. Yeah? We create products, but we also are the users of different products. When we build the app, we are users of test frameworks, compilers, continuous integration pipelines, end-to-end tests, release scripts. And really, to ship everything faster to user, we need to make our workflow way faster. So by speeding up our environment, we also iterate faster, and benefits are not only for us, but mainly for the users. So pay attention to your tooling. And let's start with, I think, first example of how slow feedback loop affects our life as developers. And in this case, let's take continuous integration pipeline, especially slow one. So we have a project with a pipeline that takes around 30 minutes to run, and the pipeline is a required check to be able to merge. So with every pull request, developer gets frustrated because they have to wait for such a long period of time. And so to be able to finish their task in the sprint, they start to batch multiple issues into single pull request. This results in a huge pull requests, and that makes code reviews extremely unpleasant. And also, they are not that in depth, they are pretty shallow, and they become useless. And after a while, we start to notice that more and more bugs sneak into production code. The architecture of the project is no longer clean. And with more bugs in production, we have to spend more time on maintenance and not feature development. Growth of our applications slows down. And maybe even to prevent some bugs in production, you add another procedures, such as another step in your pipeline, and that makes pipeline even worse, even longer. So the problem still persists. And that was the first example. The second one, with big releases, it often present in the same teams that have slow CI. Let's say we have release process that takes few days to complete because we need to run a lot of manual tests. And as a result, if it takes multiple days, we don't release to production so often. Yeah, we do that every few months and not every week and not especially daily. So let's say that you just implemented a new feature right after some release. You merged it to develop, and after 6 months, your feature is finally released to production. Now you see bugs being reported by consumers related to that feature. You have to get back to it, but you don't remember anything about it, about this task. You have to read the whole code again, understand it once again, just to fix a simple bug. When you would need to fix this feature, I don't know, let's say 1 week after it's being done, you would still have most of the information in your head, making the fix probably quite simple and easy. And the two cases I showed already were quite long feedback loops, but that's not the only ones. We have quite a lot short loops in our normal day as a developers. And one example of that slow feedback loop could be just slow build of the application. I have an application that takes around 3 minutes to be built, so that's quite a long time. So in the meantime, I decided just to switch a task, and in this case, I will just make a cup of coffee. I got back to the desk, test the change, found one more issue to solve, and the story repeats. Again, I have a few minutes to spare. I start to do something else, maybe read some article on the web. And with every iteration, I got distracted because I'm bored and I need to do something meaningful in the meantime. But that's not really efficient. As we know, we are not really good at multitasking. So switching context in this case is more harmful than we even showed with the previous feedback loop when we only impacted maybe release schedule or spending more time on reading the code. We constantly lose attention and flow just because of slow feedback loop. And let's say we want to fix this problem and do it quickly because we don't really have a time because of all the bad decisions we did in the past. We need to spend more and more time on maintenance instead of developing features. So let's say we need to shorten our slow CI pipeline. And the most of the time is spent on running end-to-end tests. So the team decides that let's exclude some not that important tests and only run part of the tests in the pipeline, and the rest will be run, let's say, before the release manually. So we did that. As I mentioned, you have a lot of maintenance and features to develop, so you don't really maintain the rest of the tests. And after a few weeks, you notice that they start to fail. No one is taking care of them. And after a while, these tests become really useless. They don't provide any value. And as they don't provide any value, to safely release, you need to do some more manual testing before that. And that makes the release process longer. So you do release not so often. You do a bigger releases every few months. And that results once again in more bugs, more issues to fix. You need to spend more time on maintenance, less on features, and the growth just slows just because you made one small wrong decision to exclude some of the tests from the pipeline instead of just fixing it correctly in the first place. I noticed during few years as a front-end developer that these feedback loops often share the same characteristics. First of all, almost all of the feedback loop you can define are not isolated. One feedback loop will influence the other, and so on. Everything is pretty much connected. The second point is that the project grows relatively slowly, and the feedback loop slows down the way the project grows. So it slows down pretty slowly over a long period of time. In a first week, the pipeline might be slower, like 5 seconds after the week of work. But then you look after a year, and the pipeline is 2 times slower than last year. It's never a sudden change. It accumulates over time, so you need to constantly monitor that. The next thing I mentioned in the previous slide, it's really hard to notice what one small decision will do in the future. It's very hard to think about consequences of decision regarding the feedback loops. And last but not least, to keep feedback loops in good shape, you constantly need to pay attention to them and address the problems. These feedback loops can probably be a good indicator of technical depth in your project. The slower the feedback loop, either release or pipeline or build, probably the bigger the technical organizational depth. So is performance really a feature, the feature? I think so. If you can drastically improve the feedback loops with a single tool, the single argument might often be enough to encourage you to switch. Let's look at a few examples of projects that won just with performance. New build tools such as Vite or ASBuild quickly gained a lot of traction and then built huge communities around them just by showing impressive speed regarding build. And instead of waiting a couple of seconds for your build, it now takes 100 milliseconds or less just to see the effects in your browser. And previously with Webpack, it was maybe possible only for some basic Hello World apps, not really for production applications that were quite huge. And for a lot of products, that was enough a reason to switch just because of the performance gains. Another use case is, I think, the new Apple M1 chip. As the hardware improvement, it will impact all feedback loops that are based on computation on your local machine. So now your app build will take 25% of the time that it used to. Your unit tests run faster, your IDE is more responsive. So they also promised increased battery time on these laptops, but from what I've seen on Twitter at least, the performance gains were the reason many developers switched just to compile JavaScript faster than with old laptop. So let's sum up a few things I mentioned. First, you need to constantly monitor your feedback loops. because it's very easy to get used to slow performance. And if you don't notice drastic improvements, such as if you don't try ES build or vid, you won't notice that your build is slow. And you constantly need to improve the cycle time. There is this one rule that improvements to daily work are sometimes more important than daily work itself, and I completely agree in this case. You should optimize in bottlenecks. So in case of the CI problem, your bottleneck was end-to-end test. So optimizing, for example, installation of dependencies won't really make that big of a difference. So any optimization outside of the bottleneck is just a waste of time. Next, reevaluate approach you are using when approaching huge growth. Usually when we design solutions, we think about current constraints, and maybe we think about the future, but we can't really predict how it will look once we achieve, for example, 100 times growth. Yeah. So every 10 times growth of your, let's say, test suite application size, you should reevaluate approach, because probably some patches on top of your existing tool won't be enough. You need to change the solution, change the approach. And just observe your environment and notice the consequences of slow feedback loops around you, how they impact your daily work, and how you can make your life better just by optimizing them. Thank you. That was all, and I'm waiting for your questions in the chat.